in digital image processing techniques are transforms, image transforms. So generally transforms are used to convert spatial coordinate values into frequency domain, spatial domain into frequency domain. So in a spatial domain, we can manipulate the pixel intensity values directly on the pixels, but in a frequency domain, so the spatial coordinates values are converted into frequency domain, and we can manipulate in terms of frequency coefficients. So here different kinds of transforms are there: Hadamard transform, Haar transform, slant transform, wavelet transform, KL transform, etc., etc. So now first we are going to see the topic on Hadamard transform. This is first H2. So this is the fixed coefficients for H2, 1, 1, 1, minus 1. Now to obtain the Hadamard transform matrix for n equal to 2, I mean we can obtain H4, 2 into 2, 4. So which is equal to this, just you substitute n is equal to 2. So H2, H2, H2 and minus H2. So already we have the coefficients values for H2. So this is 2 cross 2 matrix, 1, 1, 1, minus 1. Just you substitute. So wherever H2, substitute the coefficients values. Here minus H2, so change the sign of all the coefficients and then substitute. So here instead of plus 1, we have minus 1, minus 1, minus 1, and minus 1 means plus 1. So this is the Hadamard transform matrix for H4. N equal to 2, but we can obtain H4 because H sub is 2n, 2 into 2, 4. Then if n equal to 4, so n equal to 4 means h 2 into 4, 8. So which is equal to the h4, h4, h4 and minus h4. So already we derived h4 value. So here n equal to 4 means h2n, so 2 into 4, 8, which is equal to h4, h4 minus h4. So already we derived the h4 values for example, the first rows are all plus ones and 1 minus 1, 1 minus 1, and plus 1 plus 1 minus 1 minus 1 plus 1 minus 1 minus 1 plus 1. So this is the Hadamard transform matrix for H4. So now you substitute H4. So here H4, H4 and H4. We substitute all the coefficients values, but minus H4, change the coefficients and substitute. Then one more, so this is the Hadamard transform for H2, H4 and H8. I mean n equal to 2 and n equal to 4 and n equal to 8. So here Haar transform. So the steps for Haar transform: first determine the order of n of the Haar basis and determine n where n equal to log base to n. Then determine P and Q. So here first P value is lies between 0 greater than or equal to P and less than n minus 1. And the second case, if P equal to 0 means then Q is equal to 0 or Q equal to 1. And if P not equal to 0 means Q is lies between 1 to 2 power P. So 1 greater than or equal to Q, less than or equal to 2 power P. Then determine K. So the K is obtained from 2 power P plus Q minus 1. And determine Z. Z tends to 0 comma 1. I mean 0 by order n up to n minus 1 by n. Okay. So here if k is equal to 0 means then the transform h of z is equal to 1 by root n. So then h k of z if k not equal to 0. So it is equal to the formula 1 by root n into magnitude is 2 power p by 2. Then so here the z is lies between q minus 1 by 2 power p to q minus 1 by 2 by 2 power p. Otherwise the magnitude is minus 2 power p by 2. So here q minus 1 by 2 by 2 power p less than z less than q by 2 power p, 0 otherwise. Okay. So this is the flow of determining Haar basis. First determine the order of n and determine n small n where n equal to log base to n, and determine p and q, and determine k using k is equal to 2 power p plus q minus 1, and determine z. So using order n and we obtain the small n, p, q, k and z. So from this we can able to compute the Haar function hk of z. So now one simple problem for Haar basis for n equal to 2. So n is equal to 2. So from this n equal to log base to 2. So which is equal to the 1. So since n equal to 1 means only the value of p is 0. Q takes the value either 0 or 1. Okay. So if p is 0 means Q may be 0 or 1. So 0, 0 or 0, 1. Then determine the value of k using the formula 2 power p plus q minus 1. Okay. So here p and q combination, because if p is 0 but q may be 0 or 1. So 0, 0 and 0, 1 combination. So just substitute p 0 and q 0 means 2 power 0, 1 plus 0 minus 1. So 1 minus 1 0. K value is 0. So here 0. Then you substitute p0 and q1. So 2 power 0 1 plus 1 2, 2 minus 1 1. So k value is 1. So here 1. Then determining the value of z. So z is equal to 0 divided by capital N. Order is 2 because our problem is n for 2. So here 0 by 2 and n minus up to n minus 1 by 2. So 2 minus 1, 1 divided by 2. Okay. So here p 0 and q combination is q 0 or 1. So if k equal to 0 means transform is h of z is equal to 1 by root n. So this is formula. So 1 divided by, just you substitute n. Otherwise, if k not equal to 0, so k is equal to 1, because here k equal to 0 and k is equal to 1, two combinations. So k equal to 0 means transfer function is equal to 1 by root n. So 1 by root 2, that's all. Then if k equal to, one more thing, k value is 1 plus 1. Okay. So here k is 1 means the corresponding p and q combination is 0 and 1, p 0 and q 1. So here k equal to 1, p 0 and q 1. So just you apply the limit p value and q value in this formula. Then what is the corresponding magnitude? 2 power p 0 by 2. So 2 power 0 1. So here p, yes, 2 power 0 1. So here plus 1 and here minus 1. Then in outside the coefficient is 1 by root 2. So just you substitute. So here 0 and 1. So now k and n for 0, 0 and 0, 1 combination, the Hart transform matrix is for 0, 0 and 0, 1. K is 0 means 1 by root 2, 1 by root 2, otherwise 0 and 1. Okay. So here, so in outside coefficient is 1 by root 2. So just you multiply 1 by root 2, here minus 1 by root 2. So the final Hart basis function is 1 by root 2, 1 by root 2, otherwise 1 by root 2 minus 1 by root 2. So this is the Hart basis for n is equal to 2.